Transpose of a matrix and its properties. In this module, you will learn about the transpose of a matrix and its properties. Before we begin our study, let us recall a few things. A matrix is a rectangular array of numbers. If it has m rows and n columns, then the order of the matrix is m cross n. Now here is a matrix A. It has 2 rows and 3 columns. If we put the first and second rows in the first and second columns of a new matrix, the new matrix is called the transpose of matrix A. In general, if A equals Aij, be AM cross N matrix, then the matrix obtained by interchanging the rows and columns of A is called the transpose of A. It is denoted by A dash or A with T in superscript. Symbolically, if A equals Aij AM cross N matrix, then A dash equals Aji N cross M matrix. Let us now discuss the properties of the transpose of a matrix. The first property is the transpose of a matrix is the matrix itself. Let A be a matrix with elements 2, 1, 3, 5, 1 and 3. Then A transpose is a matrix with elements 2, 5, 1, 1, 3 and 3. The transpose of A will be a matrix with elements 2, 1, 3, 5, 1 and 3. From 1 and 2 we get the required result. The second property is the transpose of K times A is K times the transpose of A, where K is not equal to 0, is a scalar, and A is any matrix. Let A be a matrix with elements 2, 1, 3, 5, 1 and 3. Let K be 2. Then 2A will be a matrix with elements 4, 2, 6, 10, 2 and 6. The transpose of 2A will be matrix with elements 4, 10, 2, 2, 6 and 6, which is equation 1. A transpose is a matrix with the elements 2, 5, 1, 1, 3 and 3. 2 times A transpose is a matrix with the elements 4, 10, 2, 2, 6 and 6, which is equation 2. From 1 and 2 we get the required result. The third property is the transpose of the sum of matrices equals the sum of A transpose and B transpose. Let A be a matrix with elements 2, 1, 3, 5, 1 and 3, and B be a matrix with elements 1, 2, 1, 0, 2 and 3. The sum of these matrices will be 3, 3, 4, 5, 3 and 6. The transpose of the sum will be a matrix with the elements 3, 5, 3, 3, 4 and 6. A transpose is a matrix with the elements 2, 5, 1, 1, 3 and 3. B transpose will be a matrix with the elements 1, 0, 2, 2, 1 and 3. The sum of matrices A transpose and B transpose will be 3, 5, 3, 3, 4 and 6. The fourth property is the transpose of the product of matrices A and B equals the product of B transpose and A transpose. Let A be a matrix with elements -2, 4 and 5 be a row matrix, and B be a matrix with elements 1, 3 and -6 be a column matrix. The product of AB will be a matrix with the elements -2, -6, 12, 4, 12, -24, 5, 10 and -30, which is equation 1. Our transpose is a column matrix with the elements -2, 4 and 5, and B transpose will be a row matrix with the elements 1, 3 and -6. Then the product of A transpose and B transpose will be a matrix with the elements -2, -6, 12, 4, 12, -24, 5, 15 and -30, which is equation 2. From 1 and 2 we get the required result. In this module you have learned The matrix obtained by interchanging the rows and columns of A is called the transpose of A. Transpose of a matrix satisfies the following properties. Transpose of a matrix is the matrix itself. Transpose of K times A is K times transpose of A, where K not equal to 0 is a scalar. Transpose of the sum of matrices equals the sum of A transpose and B transpose. Transpose of the product of matrices A and B equals the product of B transpose, and A transpose